Today we have this problem, compare version numbers. In this video, we will discuss the easy two-pointer approach and you will be able to beat 100% of the submissions. So, in this question, we are given two strings, version 1 and version 2. These are nothing but numbers separated by full stops. So, let's say we have a string. Let's take this example only and another string 0.1. So what you have to do is you have to compare these two versions and return 1 if version 1 is greater than version 2. If they are equal, then 0. If version 1 is less than version 2, then we will return -1. So how are we going to exactly compare them? So it's not necessary that each string has equal number of revisions. What is a revision? Revision is nothing but this part, okay, a continuous part without having a dot in between. So let's say we have two strings, 1.002 and another string is 2.0.3. so this is our version 1 and this is our version 2. So what we will do is we will compare them from left to right, and for each of this revision we will see which one is greater. So as you can see that right now number 2 is greater, so this will return -1. Okay, and another thing to keep in mind is that we have to remove the leading zeros. Okay, so let's say this is our scenario now. So our version 1 has this 2 and this is 0. Now you can see that these are three different revisions in version 2 and this is the second revision only. Okay, so in second revision we see that in version 2 we have 0 and in version 1 we will ignore the first two zeros and then we will go to 2 which is greater than 0. So we will return here +1, and if those are equal, so let's take an example of them being equal. So that will be 1.0001, or even if we have 1.0010. oh no, that won't be equal because we have 1 here. We just have to ignore the leading zeros and here we have 0 here. So let's remove this 0 from here, and now you can see that it is 1 and it is also 1, and after we ignore these leading zeros this is also 1. So both of them are equivalent to 1.1 and 1.1. So we will have to return 0 here. So now let's see a detailed dry run of this problem on an example. So let's say this is our example. So what is the two-pointer approach in this problem is that we will keep an counter I for version 1 and j for version 2. So what the idea is that we will run a loop, we will run a loop, and in this loop we will uh, take every revision, the first revision that we can find in from both the versions, and then compare them revision by revision. And if revision ends, like here you have this revision for version 1 and there is no revision from version 2, so we will assume it to be 0. Okay, so we'll run a loop, and inside this loop we will run two loops, one for I and another for j loop. So in I loop we will go till we will I plus plus till we find a dot, and for j loop also we'll do j plus plus till we find dot. And what we'll do is we'll have two numbers, let's say them n1 and n2, n1 and n2, and these both will be 0 initially. And that what we are doing is we are calculating this number that's now it's just 1. It could be like 1.2501 or 35. It can have leading zeros also 1. So we are going to calculate this 250. Okay, so how are we going to calculate this 250 is that we will in this loop, for the I loop, let's say we are at here now, so we will add this number to our n1, but we also need to make sure that we are counting the places, that is the ones, tens, and of the digits. Why? Because let's say the example that we took previously was 001 and 1.010. Okay, so now if you just simply add this digit to nums, so both n1 and n2 for this revision, n1 will be 1 and n2 will be 1, and this will give string as equal, but we just have to ignore the leading zeros. Actually it should be 10. So how can we do that? We can multiply this num by 10 and this n2 here by 10, and then we will add this 0. Okay, so what we are going to do is, first for leading zeros, it doesn't matter if you multiply it by 10, you can see that in the code also, but uh, let's say that we are at in these positions now, and we are first calculating for version 1 only. Okay, so for version 1 we will add this 0 to I. So what we are going to add, version 1 of I, and then this, but while adding this version 1, we also need to make sure that we are multiplying it by 10, because if here was something like 2 or any other digit, so it should not be 3, it should be 12. So we'll multiply it by 10, and since we are multiplying it by 10, even if we multiply this sum when it has leading zeros, so 0 multiplied by 10 will give us 0 only. What I mean by this is that let's take an example for this inner loop only. So if we have a number like 0023 and just a number, let's say 32, so our initially, let's say this is n1, we are just taking an example for string to calculate the number. Now n1, it would be 0 first, then what you will do is n1 is equals to n1 multiplied by 10 plus the current digit, that is 0. So that would be 0 multiplied by 10 plus 0, again 0. Similarly, then I will move here. Again n1 is 0, so n1 multiplied by 10 plus 0 again will give you 0. But now when we are here at 2, our n1 multiplied by 10 will be 0, because n1 is 0, but now we will add 2, so it will become 0 plus 2, that is 2. And now this is n1 only, and when I goes here, now we will multiply n1 by 10 again, and this time it is not 0, it has some number. Okay, so what this does is it will ignore the leading zeros, making their sum to 0, and when we get a first non-zero digit, it will add it to the sum, and then it will keep updating its tens by multiplying it by 10. So now it will be n1 multiplied by 10 plus 3, so that is 2 multiplied by 10 plus 3, so that will be 23. And similarly for 32, it has no leading zeros, so it would be like 0 multiplied by 10 plus 3, 3, and then 3 multiplied by 10 plus 2, so that would be 32. Okay, so the same thing is what we are trying to do here is, but what we are doing is, until we find this dot, and until we find this dot, we will calculate this number, and store it in n1 for version 1, and n2 would be for version 2. Similarly, we will run this j loop on this one for the file, for the revision, and once we have calculated these both, then we would compare this n1 and n2. If n1 greater than n2, we are comparing from left and right, and for the very first revision that you find that n1 is greater than n2, we will return here plus 1, as left revision are having more priority. Okay, so now let's say that if n1 becomes less than n2, then it means that our left string has become less than right string. That's in this no, that's not in this case. Yeah, that's in this case, that it will be this one, because our okay, no, for the first file we will have n1 is equals to 1 and n2 would be 35. Okay, and we have n2 greater than n1, so we will return -1. We will return -1. We won't check these further revisions. Okay, so now we have calculated the number for revision, we have compared it, and now let's say both are equal. In this case both are equal, so we need to check the number for the next revision. For checking it, we have made this loop to go to the next position, but now if you look closely, that are I would be at the 0 uh, dot, and here j will also be at dot. Okay, so if both of them are dot, then it will again go here, and since I is now also at dot and j is also at dot, so it won't run these loops and it will be an infinite loop. It would be an infinite loop. So to avoid this, what we will do is, after doing this, we will increase I plus plus and j plus plus. So what would happen is that I would move to here and j will move to the next position. For example, I will come here and j will come at 1 in the next iteration of this outer loop. Okay, so let's the final case that left is this will handle all the cases, because if one of the version has no further revisions and one has it, like version 1 has it and version 2 don't have further revisions, so what we have done is we have initialized n2 by 0. So we will have one condition here also, that j is less than our length of version 2 and I is less than length of version 1. Okay, so if it's less than version 1, then I loop will run, this loop will run for I, but this j loop won't run, because our j has come here after this j plus plus, because j would be here and after this j plus plus it would go out of bounds, so this loop will not run, and n2 will contain 0 only, and that's what we have to do, that if there is no further revisions for anything, we have to assume it 0. So this would work for that. So I hope that you have understood this video. Thank you.